Hey guys. Good morning, everybody. How's everybody doing? Okay, well, no one wants to say hi to me. That's great. Could have used it, but never mind. I will instead talk to myself for 45 minutes. So here we go. Solve a system of linear equations. So again, we've practiced solving by hand, so I just wanted to show again how I would do this on a graphing calculator. So we start just by listing all the coefficients. So as I look at -2, 2, 1, 14, -2, 2, 1, 14, 3, -2, 1, -5, -1, 1, -2, -8. Okay, and this creates my what's called a matrix. Again, we'll talk more about matrices later on in a few weeks, but it's just kind of preliminary. Hi, Caitlin. Thank you. I appreciate that. Okay, so first thing we do, we need to get to matrix right here. So we do second x to the negative first. We go over to edit. We'll use that first one. This has 3 rows. So 3, enter. And this has 4 columns. So 4, enter. And then we just enter in all those numbers. -2, 2, 1, 14, 3, -2, 1, -5, -1, 1, -2, -8. Okay? Once we have them all entered, we quit out. So we have to go back to the main screen. So second mode takes you back to the home screen. Now we want that RREF. So again, we want matrix. So second, oops, I forgot to click second. Second, x to the negative first. We go over to the math tab. Scroll down to RREF. Enter. And then matrix A inside of that. So second, x to the negative first. 1. Close the parentheses. And we get this matrix right here. So what that tells us is, so going from top to bottom on that right column, so our first variable was x, so x equals -3, y equals 1, and z equals 6. So -3, 1, 6. And that's my final answer. Much quicker, much easier than doing the solving by hand. You still need to know how to solve by hand, but it's more tedious and easier to mess up. So on instances where you have a graphing calculator you can use, such as PFAs, or on an ACT test or something, in the future, then great. You can now know how to use your graphing calculator to solve a system of linear equations. Okay. So there's that. All right. So that's a system of linear equations. Let's then go on to a nonlinear systems of equations. So what that means is we're going to have terms now that have x squared and y squared in them. All right, quadratic terms. So it's a little bit of a different process, but very similar still. Okay, so we're still using our methods of substitution and elimination. However, it's a little bit different this time. We could get anywhere from 0 to 4 solutions. Okay, with our last problems, we either got one solution or we got none, right? 0. No solution. If we got some weird like 0 equals 12, it doesn't make any sense. So we said no solution. On these, we could also get no solution, so 0, or we could get one solution, we could get 2 solutions, we could get 3 solutions, or 4 solutions. All right, there's no really way of telling right off the bat. So just kind of be prepared that typically, though, we'll end up with definitely more than one. So let's just start looking at some examples. So we're going to do 2 examples today, and I'll show you 2 examples tomorrow. First of which is this system. So again, I can see my first equation not only has x and y, but it also has an x squared in it. So it becomes a little bit different. But we're still using our same methods. So the first thing I recognize is, well, on this more simple equation, this second one, I just have minus y. That's would probably be good for using substitution, right? Because it'd be really easy to solve this equation for y. So if I just add y to both sides, then I get 3x minus 4 equals y. Okay, that's great, because then I can take this 3x minus 4 and substitute it in for y in my first equation. Right? Solving by substitution, a method that we're familiar with. So now that first equation is x squared minus x minus y, but y, oh my gosh, minus x minus y, but y is 3x minus 4 minus 1 equals 0. Don't forget to distribute the negative. So x squared minus x minus 3x plus 4 minus 1 equals 0. Minus x and minus 3x are like terms, so I can combine those. So x squared minus 4x, 4 minus 1 are like terms, so that's 3 equals 0. And now it's a little bit more complicated to solve because I don't just have like an x to solve for, but I have x squared in here as well. So we have different methods that we've talked about solving quadratics. We can try to factor, we can complete the square, we can use the quadratic formula, but hopefully not because we hate the quadratic formula. So a lot of options, but let's first always try to factor. So looking at 3 and negative 4, so 2 numbers that multiply to make 3 but add together to make negative 4, we can do this. So x minus 1, x minus 3 equals 0. Set each factor equal to 0 and solve, so we get x equals 1 and x equals 3. So don't get tricked into stopping here. We are by no means done. All right, we have a good start, x equals 1, x equals 3, but now we need to figure out, remember, we're trying to, our final solution should be points, ordered pairs. So if I just have x values, I need to know, well, what are the y values that correspond with each of these x values? So let's figure out what y should be for both of these. All right, luckily I have an equation for y up here. So first I'll plug in x equals 1. So y equals 3x, but x is 1, minus 4. So y equals 3 minus 4, which is negative 1. So one of my points, I know that if I plug in positive 1, the y value is -1. So that makes an ordered pair 1, -1. Now for the other x value, x equals 3, so we'll do the same thing. We'll just plug it in. So x equals 3 times x, but x is 3 minus 4. 9 minus 4 is 5. So this creates a point. If I plug in 3, the y value I get is 5. Let me circle over something else. Oh no. So here are my two solutions. And more importantly, let me graph these for us. So I can try to get a visual representation of what's going on here. Just give me a second to pull this up. Okay, so typing in my two curves. So my first equation was x squared minus x minus 1 equals 0. You can see that's a parabola. And then my second equation, 3x minus y minus 4 equals 0. And if we zoom in here, it's kind of hard to tell. Oops, I forgot the minus 1. Y minus 1 equals 0. Okay, so we can see these two curves intersect in 2 points. Right? And what are those 2 points? Well, it's those 2 points that we just found. Right? So this point is 1, -1. This point is 3, 5. And those are exactly the 2 points that we solved for. Right? So visually, when we're solving a system of equations, if you're thinking about the graph of those equations, it means where do all these curves or lines intersect each other. So for this problem, they intersect in 2 spots, 1, -1, and 3, 5. Right? Exactly what we found. All right. So an important thing is just to not stop when you get here. Right? When I get 1 and 3, it doesn't mean that my answer is, 1, 3. I see that sometimes. Okay, don't do that. It means we have to take each of these individually and separately plug them into one of our original equations to solve for the other variable. Okay? How many we got here? Okay. So let's try another one. Now, looking at both of these equations, both of them have a y squared in them. Okay, so not just one of them. So I probably won't be able to do substitution here. Last one was really nice to use substitution because it just had the one y value in the second equation. So it was really easy to solve for and plug in. But here I think we're going to have to try to do elimination. All right, so here I want to get my y coefficients or my x coefficients to be the same thing but opposite sign. Okay, so we can do that in either way. We can choose to eliminate y or choose to eliminate x first. It does not matter. Since this is the only term for x in both of these, and they're both just have a coefficient of 1, I'm going to go ahead and deal with these. So I'll multiply this first equation by -1. So that would give me y squared minus x plus 11y plus 30 equals 0. Second equation, we'll just leave it as is. 2y squared plus x plus 22y plus 60 equals 0. And we'll add these together. Go column by column. So 3y squared, 0 plus 33y plus 90 equals 0. I now want to solve this. So remember, let's always first try to factor. And when we're factoring, the first thing I would try to do is do GCF. And so I see all of these have a factor of 3. So let me factor that out. So I'd get this. And to factor this trinomial, two numbers that multiply to make 30 but add together to make 11. That would be 5 and 6. Y plus 5, set it equal to 0. Y plus 6, set it equal to 0. So we would get y equals negative 5. And y equals negative 6. Just because there's the 3 out here does not mean we have y equals 3. Right? That's just a coefficient. We can't do anything with it. We're setting each of these factors equal to 0. So if we set 3 equal to 0, that doesn't make any sense. So we don't do anything with that. Just the y plus 5 and y plus 6 that gives us y equals negative 5, y equals negative 6. And remember, we have to now plug these back in to see what we get. So let's plug in negative 5 first to, doesn't matter which equation. Let's say this first equation here. So negative 5 squared plus x minus 11 times negative 5 minus 30 equals 0. And let's just simplify. Negative 5 squared is 25, but then there's the negative in front, so negative 25. Negative 11 times negative 5 would be plus 55. And minus 30 equals 0. All right, so I think we would, negative 25 plus 55 minus 30, that would be 0. So I just get x equals 0, I believe, assuming I did everything correct. Yeah, I think so. Okay. Next up, we do the same thing, but with y equals negative 6. So we'll plug that in. So we can plug it into the same equation. Negative 6 squared plus x minus 11 times negative 6 minus 30 equals 0. Negative 6 squared is 36, but there's the negative out in front, so negative 36. Negative 11 times negative 6 plus 66 minus 30 equals 0. Negative 36 plus 66 is 30. 30 minus 30 is 0. So again, we end up with x equals 0. Right, now this is a coincidence. This won't always happen that we just get the same number. Sometimes it will, but not always. So we still have to plug in both of these values to see what we get, because sometimes we might get something different. All right, so my first point, I know that if x is 0, y is negative 5. And my second point, I know if x is 0, we also could get negative 6. Each x value is connected to a y value in the ordered pair. It's not an x value with an x value and a y value with a y value. Okay. If it's an ordered pair of numbers, x value, y value, x comma y. Let's look at the graph of this again. So let me pull that back up. Let's get rid of these two. So first, negative y squared plus x minus 11y minus 30 equals 0. 2y squared plus x plus 22y plus 60 equals 0. Not O, 0. All right, I'm going to zoom out. Make sure my equations are correct. Okay, so we have this. So both of these are parabolas, one facing to the left, one facing to the right. Okay, if you know more about conic sections, you could determine that. Let's zoom in a bit. And I can see these are intersecting in 2 points. Oh, wow. I wonder what those 2 points are. 0, negative 5, 0, negative 6. All right, so no surprises there because that's exactly the 2 points that we found when we solved it algebraically. We've got 0, negative 5, 0, negative 6. Okay, so there's 2 examples of how we could get 2 solutions. Okay, these next 2 that we'll do, we'll come back and do those tomorrow for the next 2, and those are getting into higher solutions, so like 4 solutions or 3 solutions. Okay, it's and a little more complicated, just a little more steps actually, but same ideas. Okay, so I know that was kind of a short lesson, but I'm trying to keep things manageable. I don't want to overload you guys with a ton of hours worth of videos and things like that. And we're still on a good pace anyways. We're, to get through everything that we need to get through. We're still fine. So I'm okay with just, sticking through this like this. All right. I sent out an assignment with this today. You could try those now. It'll be the same assignment for tomorrow as well. So it's just like 3 practice problems that are solving these nonlinear systems. So you can do those. And a good way to check if you want to do them, if you got them right, just do what I did. Plug them into Desmos and see if the points where they intersect is the same as the points that you actually solve for. Okay, so that's a really great way to check if you're solving a system. If you graph them, does it actually, are the points where they're intersecting, are those the points that you found as well? Okay. What will we do for dual credit? How will we take the test? That's such a good question, Abby. So typically for dual credit, so MCC has still indicated that anyone who's in dual credit still needs to get the same exact content that they normally would in the normal class. So if you're someone who's taking dual credit and you're watching these streams and videos, then that's great because that's what you still need to do. And then normal dual credit also, you're required to take a final exam. I don't know. They haven't told me information about specifically how they would like for finals to look. So, I thought that they might. I'll probably still email them pretty soon here and ask them like, hey, for the final exam, do you want me to make sure that they are like taking it, while on Zoom or something? I mean, I hate doing that. I would never want to make you guys be on Zoom to like take a PFA or something, but it's possible for the final exam that we might have to do that if that's something that MCC wants. Or are they okay with it, me just sending it to you guys and then you taking it and sending it back to me? I don't know. We'll have to see about that. But as far as I know, there still will be a final exam. That still will be a thing for you guys. I just don't know what specifically it'll look like. Because the final exam is still made by me and administered by me. It's not, MCC doesn't give me an exam and say, here's what you have to give to your students. So I suppose as of now, it seems like I guess they're still leaving it up to me, but I'm going to email them soon and figure out if there's anything special they want me to do for it, like a certain time limit or, being on Zoom or something like that. We'll find out and see, but dual credit is still on. Okay, if you signed up for dual credit, then you're still getting dual credit as long as you're doing everything and passing the class. So that's still fine. Don't worry about that. And yeah, we'll just see what the final exam looks like though, because I'm not exactly sure yet. Okay. Good question. Thanks. That's good. I needed to bring that